Okay, hello everyone. So now we are fully entering the binomial theorem. Okay, so previously what we have been doing is we looked at the concept of n factorial. So what does it really mean is the n ways of rearranging it. The context doesn't it's not so important now. Okay, but we need to know the mathematical definition of n factorial, which is actually n times n minus 1 times the next number n minus 2 all the way to 3 times 2 times 1. Okay, so this is n factorial. We also did n choose r. Okay, n choose r is actually n factorial divided by r factorial and n minus r factorial, and this formula is given at the formula page. Okay, so we need to know how to use this, namely when the power of n is unknown. Okay, so we will need n choose 0, n choose 1, and so on, right? And n choose 2, and up to n choose 3. Okay, up to that point. All right, but otherwise don't worry too much. Okay, we will yeah, don't worry too much. We just need to know until n choose 3. Okay, with the if the n is an unknown. And we also looked at Pascal's triangle, right? This one, right? We look at Pascal's triangle, and we actually see that the Pascal's triangle is actually built up of 0 choose 0, 1 choose 0, 1 choose 1. Then this is 2 choose 0, 2 choose 1, 2 choose 2, right? We did this and so on, right? So all this is Pascal triangle relating to the n choose r. And at the end of the day, we did the expansion of a plus b to the power of n. We did it for some, we did it mechanically for maybe one or two, and we applied the formula for the expansion, right? So let's revisit the formula. So the formula is actually, okay, so I'm going to use a little bit of mathematical notation, but in English, this reads as the sum when r starts from 0 to n. Alright, one more time. The sum when r starts from 0 all the way to r equals to n. From 0 to n. Right? Of what? Of n choose r times a to the power of n minus r multiplied by b to the power of r. So this actually is the general term. Remember that this is our general term for our expansion. And now what we are doing over here, this piece of thing is just sum of this thing from r equals to 0 to r equals to n. Right? So it's a sum. So when you expand, right, it's actually a summation of all these things. Alright, so clear? Yeah, so this one not to worry, okay, the summation formula not to worry. It's just that we keep repeating this process to add. So for those taking computing, right, this is actually your while loop, right? The while loop, right? While r from 0 to n, so it's or it's a for loop for 0 to n and so on. Okay, so that aside, so this is what we so call as binomial theorem. Okay, so this formula above is our binomial theorem. Alright, so let us add one more thing over here. So the general term, so let's say if we were to look for a specific term, if we are looking for a specific term, we can use the formula for general term, t term r plus 1. Okay, we start from term 0, term 1, term 2, term 3, so that's why it's r plus 1. So this is going to be equals to n choose r. So this is the term a to the power of n minus r and b to the power of r. Okay, so this full chunk over here, right, is our binomial theorem. Okay, so this is what we get for binomial theorem. And at the same time, the definition for the n choose r would be equals to n factorial over r factorial multiplied by n minus r factorial. So this is the formula for n choose r, which we will be using later. Okay, so let us take a look at try 7, right? And let us apply this binomial theorem to things when they are not a and b, right? So when a and b are some other things, this is where we see the power of this binomial theorem. So now we are looking at the first 4 terms, okay? we want to expand this for the first 4 terms, right, in descending powers of x. Okay, in descending powers of x. So the thing for descending powers of x is that you notice that this a, right, previously when we do a, okay, if you observe, previously when you expand, right, the powers are decreasing, right, and for b, the powers are increasing, right. So let's say if you want to look for decreasing power of a, so decreasing power of x, so meaning this x must be in front, right, the higher power must be in front, the lower power behind, then you can really see that the a will actually decrease the power. Okay, so this is the first thing to take note. Okay, so for descending powers of x, right, so this one over here, the trick is, okay, let me put one trick. So the trick over here is, okay, leave the higher x term, okay, leave the higher x term as a, right, so you put in front. Okay, all right, so let's take a look and see how do we expand. So over here we have our 3x plus 2 to the power of 6. Okay, so let's try to expand over here. So n is 6, a is 3x, so this is a, this is b, this is n, right? And when we expand for the first few terms, we have term 0, term 1, term 2, term 3, right, and so on and so forth. But we only need the first 4 terms like this. So r equals 0, r equals 1. So we will apply this repeatedly, right, with different values of r. So r equals to 0, r equals to 1, r equals to 2, r equals to 3 over here. Okay, so let's try and see. So over here, this is n choose r of the a. So a is 3x to the power of 0. We start with 0. And then we have 2 to the power of 6. A to the power of n minus r. So a to the power of 6 and 2 to the power of 0. Okay, so a will start with the highest power. Okay, plus, okay, 6 choose 1 of 3x to the power of, after 6, right, it is 5. And then this would be 2 to the power of 1. Okay, so you see the n minus r in work, right? 6 minus 1 is 5. And then this is just 1. Okay, so let's look for the third term. The third term is 6 choose 2 of 3x. Okay, 3x to the power of 4 and 2 to the power of 2. And last term, 6 choose 3 of a power 3 and 2 power 3. And then the list goes on and on. Okay, so sadly I don't have space to write the whole thing, but ideally we need to write the one whole stretch. Okay, so what is this? So we use our calculator. Okay, or maybe we can, yeah, we should use our calculator. So let's do this. So we do, this is going to be 6 choose 0. So what is 6 choose 0? 6 choose 0 is 1 multiplied by 3 to the power of 6, because when we expand it's 3 power 6 x 6. So this would be 729 of x power 6. 2 power 0 is 1. Okay, we tidy up later. Plus 6 choose 1, your calculator will tell you 6 over here. Now 3 to the power of 5. So 3 to the power of 5 is 243 times x to the power of 5, right? Then times 2. So this would be the second term. Okay, third term. So 6 choose 2, so your calculator will tell you this is 15, right? 3 to the power of 4 is going to be 81, so 15 times 81, and x to the power of 4 times 2 squared times 4. Last one, plus 6 choose 3. 6 choose 3 is 20 times 3 cube. 3 cube is 27. Then we have x cube times 2 cube, so times 8. Plus dot dot dot, because we add the plus dot 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 because it's ongoing, right? We didn't expand the full thing, there's more. Okay, so let us tidy up over here. So I'm going to have 729x power 6 plus, okay, the rest you can use your calculator to simplify, right? 6 times 243 times 2, so I get a 2916 of x to the power of 5 plus 15 times 81 times 4. So this is 4860 x to the power of 4. Then the last one over here, 20 times 27 times 8. So this one would be 4320 of x to the power of 3 plus this, okay, plus the rest. So we are done already because we just need to expand until the first 4 terms. So we double check and see, we have 4 terms, right? And it is in descending powers of x. Do you see this? Descending powers of x. Right, so we have this one over here. Right, so this is how we apply the binomial expansion. So how do we apply again? Is 6 choose something, 3x to the power of 6 minus r, and then 2 to the power of r. Okay, so like that. So a power n minus r, b power r. So we've just followed the use of formula. Right, so then unless the n is unknown, we will just use calculator to calculate n choose r. Okay, let's take a look at B. For part B, okay, part B will look easier because I have more space now. So x squared minus 2 over x to the power of 8, right? So again, for descending powers of x, the a, I will leave the higher power of x, the higher x term as a. So what do we have over here? So this is n equals to 8. This is n. This is a. This thing is b. The negative 2 over x is b. Important. The negative important. Okay. So over here we have, okay, n choose r of a to the power of n minus r. N minus r. Times b. So the whole thing is b. B times r. B to the power of r. Plus, okay, 8 choose r. A to the power of 8 minus r, so this is 7, and b to the power of r, plus 8 choose r, a to the power of n minus r times b to the power of r. Do you see the trend now? Last one, plus 8 choose r, so now r is 3, of a to the power of n minus r times b to the power of r. Okay, so now you see this? Okay, so let's evaluate. Okay, so we have 8 choose 0, x squared to the power of 8, so it's x 16. Alright, so 2 to the power, so this thing over here, this is equals to 1, correct? Anything power 0 is 1. So this one will just multiply by 1. Okay, next one. 8 choose 1 is 8. X squared to the power of 7 will be x 14. Right? Then the next one will be this one to the power of 1. So I need to multiply by negative 2 over x, like that. Okay, so for the second one, for the next one, 8 choose 2. Calculator will give you 28. Right, so 8 choose 2, calculator will give you 28. This one would be x to the power of 12. This one over here, when we expand, so negative 2 square will give me 4, and this will be 2 square below, x square below. Okay, last one, 8 choose 3, so this is going to be 56, right? 56 to the power of x square power 5, so this is x power 10. Then this one I need to multiply with negative 2 over x cubed, so negative 2 cubed would give me a negative 8, and this would be x cubed at the bottom, right? And it continues, right? But we only need the first few terms. So let's simplify this now. So over here I have an x power 16, right? First term is x power 16. Second term over here I have the 8 and negative 2, so this will give me negative 16, x 14 over x, so I will have an x 13. Okay, next one over here, okay, 28 and a 4, so 28 times 4 will give me 112, and then x 12 divided by x squared, so I will have an x 10. Okay, now last one is 56 times negative 8, so 56 times negative 8 will give me a minus 448, right? So x power 10 over x cubed, so I will have an x power 7, like that. Okay, so if you notice, right, x16, x13, x10, x7, they don't have anything in between. We don't have like x to the power of 15, x to the power of 14. It's just like straight away the term will jump nicely. Okay, so for this one over here, right, the term actually jumps nicely. So we just yeah, follow the, once you see the trend, right, you can just verify that the trend is like that. So like the x power decreases constantly. Okay, so quite nice. Okay, let's take a look at C. Now C, we need a few preparation work. Okay, why? Because we are expanding 2x plus 1 to the power of n, the annoying n. And then we are going to need n choose 0, n choose 1, n choose 2, and so on. So we may need this. Okay, we may need to evaluate this. So before we start expanding, it will be good to look at what are these n choose somethings, right? So for the first one, n choose 0. If you can remember that this is 1, great. If you cannot remember that this is 1, sure, let's follow me. So this is, let's apply the formula over here where we have n choose r is equals to n factorial r factorial n minus r factorial. Okay, so I'm just applying the formula n choose 0. So this is going to be n factorial over the r factorial over n minus this one factorial. Correct? So technically speaking, I have an n factorial over 0 factorial times n factorial. Okay, do you see that? Right, do you see that? This one is equals to n factorial, so I can just cancel this, and then 1 over 0 factorial is equals to 1. 0 factorial is 1. Okay, so n choose 0 is 1, right? N choose 1 is going to be n factorial over, this is 1 factorial, and n minus 1 factorial. So then we have n factorial divided by n minus 1 factorial. So let's expand and see. So we have n factorial over, oh wait, n factorial, right? I can rewrite as n times n minus 1 factorial. Okay, and whole thing divided by n minus 1 factorial. So you can see that something cancels away. We are left with n. Okay, so this is n choose 1. Let's take a look at n choose 2. N choose 2, so we have an n factorial. Okay, n factorial over there. Okay, so for part C, right, if you notice over here, we are going to expand 2x plus 1 to the power of n. Right, so one obstacle that we may have is the n, because we need to do n choose something. Right, now n is the unknown. So what are we going to do is, based on this formula over here for n choose r, we are going to derive some standard answers. But when it comes to O levels, right, it will be good to remember some of these n choose base. So we need to know what is n choose 0, n choose 1, n choose 2, n choose 3. If you cannot remember, then you derive on the spot. But it will be good to know these standard results so that it will be faster when you do in O levels, in the proper exams. So before we start, right, let us derive some of these things over here. So before we start to expand, we try to look out for what is n choose 0, n choose 1, n choose 2, n choose 3. Okay, so n choose 0 is going to be n factorial, okay, based on this formula, n factorial, that over r factorial and n minus r factorial. So this, we can simplify this as n factorial over 0 factorial is 1, and this is n factorial at the bottom. Okay, this thing over here, this is 1. Okay, so n factorial over n factorial, this is equals to 1. Very straightforward. So now, what is n choose 1? Okay, n choose 1 would be n factorial over r factorial times n minus r factorial. So this will be equals to n factorial over, now 1 factorial is just 1. Okay, this one is just 1. And then I will have an n minus 1 factorial below. Let me rewrite this as n times n minus 1, n minus 2, and so on, right? So technically speaking, this is n times n minus 1 factorial over n minus 1 factorial. Okay, so now you can see that something cancels out and we are left with n. Okay, cool. Let's take a look at n choose 2. So what is n choose 2 over here? This would be n factorial on top over r factorial and n minus r factorial. Okay, So we have some work to do. We have an n minus 1 on top. So n minus 1 on top, right? Let me write this as n times n minus 1 times n minus 2 factorial. So n minus 3, n minus 1, and so on. Right? I just stop at n minus 2 and I put the factorial there. Over 2 factorial is just 2. Okay, 2 times 1. Correct? Multiplied by n minus 2 factorial. So just nice, I can cancel this n minus 2 factorial. So this is going to be n times n minus 1 over 2. Okay? So this is your n choose something, n choose something, n choose something. Okay, let's do the last one over here. Okay, I'm going to try to do the last one. And let me squeeze in a bit so that, that it's easier to see for y'all. Okay, and then we can just expand everything. Wow, like not enough space here. I don't think there's enough space. Okay. In that case, let's do it below lah. Okay. So what is n choose 3? Right, so n choose 3 would be n factorial over r factorial and n minus r factorial. Okay, so like what we simplify like n choose 2, right? We are going to rewrite n factorial as n times n minus 1 times n minus 2 times n minus 3 times n minus 4 and so on, right? But I'm going to stop at n minus 3 and I leave the factorial there to represent everything behind. Over 3 factorial is 6. Okay, 3 times 2 will give me 6. And then n minus 3 factorial. So what we need to do is just to cancel these two. And we have n times n minus 1 times n minus 2 over 6. Right, so this is n choose 3. Okay, n choose 3. So with all this in mind, with all these results in mind, let us now get ready to expand 2x plus 1 to the power of n. Right? So what is... Okay, let me expand here. So what is... Okay, so 2x plus 1. Okay, to the power of n. So over here, I will start with n choose 0. And then a, which is 2x to the power of n. And I have b to the power... Sorry, n minus r. And b to the power of r. Okay? Plus n choose 2 of a to the power of n minus 1. And b to the power of 1. Right? Do you see it? Of r. Do you see this? Then I have an n choose r. Sorry, jump too fast. This should be 1. Okay? So the next one should be r is 2. So this would be a to the power of n minus r and b to the power of r. Okay, one last term. Ayo, why need to... why like that now? Okay, let me squeeze in a bit more. Let me squeeze in this one a bit left. Okay, so one last term over here. So we have our n choose 3 of a to the power of n minus r and b to the power of r. Okay, so mainly like that. Okay, so now it's time to put in all these n choose somethings into the formula. Okay, so over here n choose 0 is 1. We have times 2 to the power of n times x to the power of n, and 1 to the power of 0 is just 1. Okay, so then the next one over here is, what is n choose 1? Now, results above, n choose 1 is n, right? So this would be n times of 2 to the power of n minus 1 times x to the power of n minus 1 times 1. Okay, sure. Plus n choose 2. n choose 2, we have this result over here, n over n minus 1 over 2. n times n minus 1 over 2. So we have n times n minus 1 over 2 for this thing. Next, we expand this to give me times 2 to the power of n minus 2, x to the power of n minus 2. And 1 to the power of anything will just be 1. Okay, last term, plus n choose 3 is over here. So I have an n minus 1, n minus 2 over 6. And 2 to the power of n minus 3, and x to the power of n minus 3, and 1 to the power of 3 is just 1. And then I need to add the plus dot dot dot. Okay, So let's simplify. So we have 2 to the power of n of x to the power of n. We can just leave it like this. Plus, okay, so 2 to the power of n minus 1 times n times x to the power of n minus 1. Okay, so next one over here, let me simplify a bit. So 2n minus 2 divided by 2. So I have a 2 to the power of n minus 3. Okay, 2 to the power of n minus 3 times n and n minus 1 to the power of x, x to the power of n minus 2. So you see, right, there's a coefficient and the x term. There's a coefficient and the x term. This is the coefficient and this is the x term, right? And last but not least, plus, okay, I'm going to just combine this. So 2n to the power of 3 times n minus 1 times n minus 2 over 6 times x to the power of n minus 3. So I'm just going to leave it like this. Okay, so we have one big fat coefficient in front and the x term over here. Okay, so this is how we do for try 7 when the powers is like n. Okay. Okay, so next we look at page 147, try 8. So now instead of expanding, right, we want to find what is the, like, q and so on. When we expand, there's some unknowns that we need to settle. Okay, so we need to find the value of p, value of q, value of r, which is just nice. So means if you notice over here, right, we are expanding 1, 2, 3. We are expanding for the first 3 terms. Okay, we just need to expand 1 term, 2 term, 3 terms, right? So we expand until r0, r equals to 1, r equals to 2. So just 3 terms. Okay, so let's I'm leaving the formula below so that we can refer, right? So over here, let's try to expand and try to compare coefficients so that we can answer what it says. So let's expand this. So 3 plus px to the power of 5. So n is 5, a is 3, b is px. So this is going to be n choose r times a to the power of n minus r times b to the power of r. Okay, first term. Second term, n choose r, 3 to the power of n minus r times b to the power of r, plus n choose r of a to the power of n minus r times b to the power of r, plus so on and so forth. Okay, so let us simplify this. 5 choose 0 is 1. 3 to the power of 5 is 243. Right? And this term over here, this is equals to 1. Okay, so I'm just going to like times 1. Now 5 choose 1 is 5. 3 choose 4. Okay, you can use calculator. 3 choose 4 is going to be 81. Right? So multiplied by px. Plus 5 choose 2. Your calculator will tell you is 10. 3 cubed is 27. And then we have a p square x square. And so on and so forth. Let us let us what do you call this? Let us simplify a bit. So this is 243 plus 5 times 81. So this is 405 times px plus 10 times 27. So this is going to be 270 of p square and x square, right? And let us now compare with q minus 135x plus rx square, and so on and so forth. Okay, so let us compare coefficients, right? The x term and the x square term. Okay, let's compare coefficients. So first one, comparing constants. Okay, so what is the constant term over here? So the constant term over here, q and 243, correct? So this would be q is equals to 243. Okay, perfect. So then next we compare the x term. Okay, so this is the x term and this is another x term given in the question, right? So over here we have 405p is equals to negative 135. So this is p is going to be equals to negative 1/3. Okay, so next let's compare x square terms. So this is like polynomial, comparing terms. Okay, compare x squared terms. So I have an r is equals to 270p squared, right? So this will be 270 times p squared. So 270 times this. So r is going to be equals to 30, like that. Okay, so we expand and then we compare terms to evaluate. Okay, so the first kind, try 7, is expand. Second kind is there's some unknown, we can expand and compare coefficients. Okay. Okay, so the next kind of question over here is for when okay, so we want to expand 1 plus x squared to the power of 14 in try 9. Okay, in ascending powers of x, so we ignore that first. Okay, find the 8th term. Okay, so now are we going to expand all 14 of them just to look for the 8th term? We actually don't need to do so, right? We don't need to do so. We just need to isolate this and just make use of this general term to find the 8th term. Okay, and when the coefficient is x to the power of 10, right, x to the power of 10, so means that we have to find a certain way to, we don't need to find the whole thing, right? And to find the coefficient, we don't need to do that. It's going to be a waste of time. We're going to make use of the powerful binomial theorem, which is this, to find the general term. Okay, so here the weapon is general term. Now, then the next thing to take note is in ascending powers of x. So this is the 1. Now, previously, let me recall a bit. So when we have a plus b to the power of n, correct? The power of a is descending. The power of b is ascending, right? So actually, if we want ascending powers of x, the x term must be b. Okay, so means that for this one, right, the trick is for ascending powers of x, we leave the x term as b in the expansion. Okay, so we make it to be b, we swap the places to be b, and then we expand. Okay, so let's do this. Okay, so before we start, right, it will be good because we are looking at the specific term. Now instead of expanding, we're looking at the specific term, so it will be good to obtain the formula for our general term. So the general term is tr plus 1, but the formula over here is going to be based on r. Okay, why? Because the first term is t1, but the r is equals to 0. Second term is t2, but the r is equals to 1, so it's always 1 less. Okay, or the term number is 1 more. Okay, so let's do this. So the general term for this expansion, right, will be equals to, the n is 14, choose r, because now the general term is going to be a generic r. Okay, so 14, choose r of a to the power of n minus r times b to the power of r, like that. Okay, so let me simplify a bit. So this thing over here is going to be 1, because 1 to the any power of anything is 1. Then this one over here, I can make use of law indices to make it easier. So the general term tr plus 1 is going to be equals to 14 choose r times x to the power of 2r. Just nice. Okay, so if we are looking for the 8th term, okay, for the 8th term, so means for t8, right, for t8, r plus 1 is equals to 8, correct? So this means that r is going to be equals to 7 in order for us to get t8. Okay, so r equals to 7. So means that t8 over here is going to be 14 choose 7. Okay, so based on this formula, 14 choose 7 times x to the power of 2 times 7. So over here we have 14 choose 7 is going to be 3432 times x to the power of 14, just like that. Okay, so this is the 8th term. Okay, so one more time, the formula over here is for tr plus 1, the r plus 1 term. So when the term is the 8th term, r plus 1 is equals to 8, so r is equals to 7 over here. Okay, then we can sub in into the general term to find the term. Okay, next one. So for the second part over here, which is the more interesting one, so find the coefficient of x10. So means that we need to look for the x term over here, and when the power is equals to 10. So when for x10, right, so for the x to the power of 10 term, right, so the power is going to be equals to 10. So it means r is going to be equals to 5. So it means that the coefficient, right, the coefficient of this term is going to be just the front part, right, because this is the variable part, correct, and this is the coefficient part, right, so we just need the coefficient in front. So over here the coefficient, the number is 14, choose 5. Okay, so 14, choose 5, the r is 5, so this is going to be 2, 0, 0, 2, just like that. So the lesson of the day is we don't have to expand every single thing to find a specific term. So number one, when we're looking for the 8th term, r equals to 7. Number two, in order to look for the x power 10 term, x10 term, we need to let the power equals to 10. And we find the r so that we can sub in to find the coefficient. Okay, so this is try 9. Okay, so now let's take a look at try 10. Okay, so now we have try 10 over here. So using the general term, it's very nice they give us the general term, but otherwise we can refer to formula sheet to find the indicated term in each of the following expansion. So we want to look for the middle term for 2 minus x to the power of 3 to the expanded to the power of 6. Okay, sure. So when you take note, yeah, when we expand a plus b to the power of 6, right, remember how many terms do we have? Okay, a plus b squared, we have 3 terms, right? A squared plus 2ab plus b squared. A plus b cubed, we have how many terms? 1, 3, 3, 1. So we have 4 terms. Remember the coefficient, right? So a to the power of 6, right, we actually have 7 terms, right? 7 terms. 7 terms. So which one is the middle term? So this is term 1, term 2, term 3, term 4. So we are looking for term 4 actually. Okay. So actually what are we going to do over here is, now, so for A, so for the middle term, okay, which is term 4. Now, what is the value of the r? R is going to be equals to, r is equals to 3, right? Because this would be t r plus 1. So it means that this one is equals to 4, r is equals to 3. Okay, so this is what we have over here. Okay, so how do we do this? So in order to look for the middle term, we just need to do that. So the middle term, so t4 is going to be equals to n, so n is 6, choose 3, r is 3, okay, n choose 3 of a to the power of n minus r times b to the power of r. Okay, so if you cannot see, this would be like this, n minus r. Okay, so let us use calculator. Right, let us use calculator to evaluate this part over here. So this is 6 choose 3. 6 choose 3 times 2 to the power of 6 minus 3, so 2 to the power of 3. Okay, so I'm over here, I get a 160. Then negative x cubed will be a negative x power 9, because negative cube will be negative, x cubed will be x power 9. So this will be negative 160 of x to the power of 9. So this is the middle term, the 4th term. Okay, now for b, okay, for b is a bit special because when we're looking for the term independent of x, so it will be good to find the general term first, because unlike the previous one we can find the term directly. But for b, it's a bit difficult to find the term directly, so we need to make use of the general term. So let's find the general term first. right? So for the general term, tr plus 1, so this would be n choose r. The n is 9, the r is the unknown r first, of a to the power of n minus r, right? And we have a b to the power of r. So over here, it will be good to use law of indices to consolidate all the x's together. So over here, let me write down all the coefficients that I have. The coefficients I have is 9 choose r and the 2 to the power of r. Do you see that? 9 choose r and 2 to the power of r. So I write them in front, coefficient. Then next over here, I use laws of indices to get this and law of indices to get this. So over here, my law of indices tell me that this is going to be x to the power of 18 minus 2r, right, for this first one over here. And for the second one over here, this is going to be times 1 over x to the power of r. Okay, let's do a little bit of laws of indices again. So it's 9 choose r times 2 power r. And then the coefficient, we keep it like this because it's the simplest form. Then we have an x to the power of 18 minus 2r minus r. So this is going to be minus 3r. Okay, so you see this? Minus 3r. Okay, so now, once you simplify this already, so in order to look for the term independent of x, okay, for the term independent of x, so means that this power over here, for the term independent of x means I don't see any x, so means that this power over here will be power of 0. So means that the power 18 minus 3r is going to be equals to 0. So over here, r will be equals to 6 when you solve for r. Okay, so now we are going to look for the term independent of x, okay, or the constant term. So it means that t6 plus 1, so this is going to be t7, then 9 choose r, okay, so this is going to be 2 to the power of r times x to the power of 18 minus 3r. So this one over here, 18 minus 3r, because this will be x to the power of 0, and this will be equals to 1, correct? 18 minus 18, so what is left is just calculator, 9 choose 6 times 2 to the power of 6, so this will give me 5376, right? So term independent of x don't have the x, so it's just a constant term. Okay, so this is try 10. Okay, so we have our second last question of the day, right? Second last question of the day. So over here, same thing, we are going to find the term independent of x in this expansion. So now the problem is, right, we have this kind of expansion. Okay, now we have two brackets to expand, right? So the first bracket is the 2 plus this one square. So this one we don't really need binomial theorem. We actually know how to expand this from set 2. A square plus b square plus 2ab. We will use that to expand this. And at the same time, okay, we also have this expansion over here. Okay, we need to expand this thing over here. Okay, alright, so now the thing is that let us slowly expand this one by one. Okay, I'm going to expand this first using the general term, because in order to look for the term independent of x, right, I am also lazy to expand everything, right? So the thing is, I'm going to find the general term for this, and at the same time I will expand this fully, and then I'll just I will multiply and expand accordingly. Okay, so I will show you how to do this. So first, let me obtain the general term for this. So the general term of, okay, so 1 minus 2x to the power of 7. Okay, so this will be equals to, okay, so this will be equals to like this. So, 2x, okay, power 7. So this will be equals to, okay, very nicely. Okay, so this will be equals to n choose r of, first one is a to the power of n minus r, and I have a b to the power of r. Okay, so very graciously, this one is 1. So I can just simplify this to 7 choose r to the power of no, times 2 negative 2x to the power of r. Okay, so if I want to like rewrite this nicely, so negative 2 power r and x to the power of r. Okay, let me rewrite like this so it's a bit clearer. Okay, so then let me now find the general terms of this one. So general terms of 2 plus 1 over 2x whole thing square times this to the power of 7. Okay, so the general terms will look something like this. So when I expand this, this will be, okay, so this thing will be a square, right? So I'm going to have a 4 plus 2 times a times b, right? So over here I have a 2 times a times b, right? Plus b squared. So over here this would be my b squared, like this. Okay? Then I need to multiply with 1 minus 2x to the power of 7. Okay, so let me simplify this and see that this one is very nicely 4 plus 1 over, so this is not 1 over, so 2 over x plus 1 over 4x squared. So this is the first bracket. Okay, and the second bracket I'm going to replace it with this. So the second bracket I'm going to replace it with this. Replace this with 7 choose r of negative 2 to the power of r times x to the power of r, like this. Okay, now then let me expand one by one because this is one full term, correct? So let me expand this, expand to this one, expand to this one. Do you see how I expand? Right? So the first one times 4 will give me something like 7 choose r, right, times negative 2 to the power of r times 4 times x to the power of r, like that. Okay, first one. Second one would be a 7 choose r in front, then I have a negative 2 to the power of r times 2, right, times 2, and then x power r over x. This is actually x to the power of r minus 1. Okay, you see this? This one now multiplied with this. So the 2 and this I put together, and the x power r minus 1 because it's x power negative 1. Okay, then plus the next one would be 7 choose r of negative 2 to the power of r. Okay, so then this would be x to the power of r minus 2. We still have a 4. We still have a 4. So actually I have a, okay, so negative 2 to the power of r over 4 times x to the power of r minus 2. So the 1 over 4 times this one, I put these numbers together because these are my coefficients. Okay, and then x power r and x over x squared. So this will be x power r minus 2. Okay, so these are the general terms of this. Okay, so what are we looking for again? We are looking for the term independent of x. Okay, so this one, right, it is independent of x. So for this term over here, okay, for this term over here, it is independent of x when r is equals to 0. We just need to look at this term over here. Okay, so let me highlight this one. When r is equals to 0. Okay, second one, let's focus on this x. So for this particular term, right, so this is going to be independent of x when r minus 1 is equals to 0. So r will be equals to 1 over here. Okay, for this term, when we want to locate the term. Okay, last but not least, let's take a look at this one over here. Right, is this term over here. Right, so this term is going to be independent. Okay, so this is going to be independent. So means that there's no x. Okay, independent of x when the power of x. So when r minus 2 is equal to 0, when the power is equal to 0, so r over here is equals to 2. Okay, so over here what we need to do is just we need to add them individually. Okay, we need to add them individually. So what do we do over here is, okay, so the term independent of x would just simply be, okay, so we just take this when r equals to 0, take this when r equals to 1, take this when r equals to 2. Okay, so we just need to do that. Okay, so this is just going to be equals to, now 7 choose 0 of negative 2, okay, let me put in red color, right, to the power of 0 times 4 and x to the power of 0. Okay, second one is 7 choose 1, because this is when we get the term independent of x. So r is 1, and we have a 2 times r to the power of 1 minus 1, which is going to give us 0, plus 7 choose 2 of negative 2 to the power of 2 divided by 4 times x to the power of 2, then minus 2. Okay, so this is the term independent of x. So let us simplify over here with our calculator. So the first one is going to be, okay, this is 1, this is 1, this is also 1. So I'm going to be left with a 4 over here. Okay, second term, 7 choose 1 is 7, negative 2 to the power 1 is just negative 2 times 2. Okay, and this one is just become 1. Yeah, x power 0 is just 1. Okay, then the next one, 7 choose 2. 7 choose 2 is 21. Okay, times, okay, over here, negative 2 square. So this is going to be 4 over 4. So this is 1. Okay, and over here, I have an x to the power of 0. So this is just 1. Okay, so let's add all of this together. So 4 plus 7 times negative 2 times 2 plus 21. So this is going to be negative 3. Okay, so the term independent of x is equals to negative 3. Okay, so technically what are we doing? So technically what are we doing? So if you want to look at the okay, so if you want to look at this view, so we have our 2 plus 1 over 2x square with the expansion below, and we have our 1 plus 2x 1 minus 2x to the power of 7. Okay, so when we look at this, right, we can think of it as like the box method like this, right? So this one, when we expand, right, I have a 4 plus 2 over x plus 1 over 4x squared, right? When we do the box method of expansion, is like this. Then this one over here would be like, 7 choose 0 of a to the power of n, a to the power of this one to the power of 0, plus 7 choose 1 of this, plus 7 choose 2 of this, right, and so on and so forth, correct? So technically speaking, right, what are we doing is we are just expanding like this, expanding like this, expanding like this, correct? And we're just looking for the term with no x. So the term with no x is actually this term over here, this term over here, and this term over here. So instead of just expanding the whole thing out as one big table, okay, instead of expanding the whole thing like this, right, what are we doing over here is just to isolate. I want this, I want this, I want this. Okay, so I just want this, I just want this, I just want that. Okay, so this is the very abstract part for this kind of expansion. So don't worry yet. Okay, this one will seem like very how to call this, abstract and very difficult now. Okay, but don't worry too much. When you do much more, right, you get the hang of it actually. But the concept is like this. The main concept is, okay, so this is the full concept, the full analogy, the full concept. It's just that this one over here, right, this one over here, how do we locate term independent of x is when this power of x equals to 0. If you're looking for the x term, this power must be equals to 1. If you're looking for the x square term, these powers must be equals to 2. So it's just an application like that. Okay, so I hope you understand this, and I hope you are clear, like you roughly know what is going on, and then when you do more practice, then you'll see how it really works. Okay, so let us do one last question, very last question. Okay, so we are looking at actually question 17 of page 152. Now the reason why I chose this question is because of the power n, right? The very difficult power of n. Yeah, so we want to I want to like try to do this together with you so that you are not worried too much. Okay, so let's take a look at part 1. Right, part 1, write down the first 3 terms of this expansion in ascending powers of x. So ascending powers of x means that the x term, right, will be b. Right, so the x term must be at b, and n is an integer greater than 2. Sure, so means that we need to find the first 3 terms. Okay, so how do we find the first 3 terms is will just apply the formula directly. Okay, and let me write down the formula over here. So the formula for this would be the summation, the sum of n choose r, a power of n minus r, b power r. Okay, so let us do this. So the first 3 term, because I don't know the n, so I'm just going to leave it as n, but the first one is r0. So n choose 0 of a to the power of n minus r and b to the power of r, plus n choose 1 a to the power of n minus r and b to the power of r. Ayo, no space, yeah, very annoying. Okay, plus n choose 2 and then a to the power of n minus r and b to the power of r, like that. Okay, and so on and so forth, right? So we cannot stop here. We have to evaluate our n choose 0, n choose 1, n choose 2, and actually we can make use of the results that we've known earlier. Okay, so previously n choose 0 is 1, n choose 1 is n choose 2 is going to be n minus 1 over 2. Okay, so we need to know these results to do calculations a bit faster. So over here we have n choose 0. So n choose 0 is 1. 2 to the power of n minus 0 is 2 to the power of n. And then this one, anything to the power of 0 is 1. Okay, the next one over here, plus n choose 1 is n times 2 to the power of n minus 1 times negative x over 2 power 1. Okay, next one, n choose 2, so n minus 1 over 2. Then I have a 2 to the power of n minus 2 times, okay, I have an x square over 4. Okay, or I can put it as x square over 2 square. Okay, like that. Okay, and so on and so forth. Okay, ayo, let me just reposition this over here so that it looks nicer, right? Yeah, like this. Wow, no, not clean. Like this. Okay, let me put this here. Okay, yeah, this looks cleaner. Okay, this looks much cleaner. Okay, like this. Okay, so let us simplify a bit and let us like tidy up on what's going on over here. So this one, I have a 2 to the power of n minus, okay, because of this minus all the coefficients in front. So this one will be, okay, 2 power n minus 1 divided by 2. So this would be n times 2 to the power, okay, n times 2 to the power n minus 2. And then I have an x over here. Okay, so this is my coefficient. Okay, and then I need to plus. Okay, so now I have 2n minus 2, right? Divide by 2 square. So over here I will have my n minus 1 and 2 to the power n minus 5. Okay, because need to minus 3 of them, like the power minus 3 of them, and then I have an x square. Okay, so I have this term, this coefficient in front, and x square. Okay, so I will leave my answer like this. Okay, there's no other way to simplify already. This is the simplest form. So I collect all the two together as one. Okay, so mainly like that. So this is the expansion when the n is the unknown. Okay, for the other time, you just expand when you know the n, and then you can find the value of those n choose r. But now n is the unknown, so we have to leave it like that. Okay, now then the first two terms in the expansion. So next part, so the first two terms is this, find the value of n. So what we're going to do is I'm going to expand this one over here. Okay, I'm going to expand. Okay, so over here I have 1 plus 2x times 2 minus x over 2 to the power of n. So I'm going to expand this, right? I'm going to expand this with this ungodly thing. Okay, I'm going to expand with this. Okay, so now it's just to expand mechanically, right? So I have 1 times this, and I have a 2x times that. Okay, and after I expand, right, I need to group some of them together, and I want you to see how I group. Okay, so let's take 1 times that first. So 1 times that, very straightforward. I have a 2n minus n times 2 to the power of n minus 2 of x. Okay, so the first one very easy, is just copy, because it's just 1 times of the thing. Okay, so this one is just 1 times this, 1 times this, 1 times this, and so on. Okay, next one is 2x times this, 2x times this, right? So first one, 2x times 2 power n. So I will have 2 to the power of n plus 1 of x. Okay, plus 2x times this one over here. So this would be 2n minus 2 plus the times 2, right? So I will have a n times 2 to the power n minus 1, because the power increased by 1 when I multiply by 2. Okay? Oh no, x square. Because of x times x, forgive me, x square. Okay? Next term over here, 2 times this one, so the power will become n minus 4. So plus, okay, and so on and so forth. Okay, actually I don't need to do so much already, because if I notice, right, I will just need to expand until x square, right? And if I expand this over here, this term and this term, I'm going to get an x cube. So technically I can just stop until x square. Okay, I can just stop at x square. Okay, so let's take a look at this now. So over here we need to find the value of n. So when we compare coefficients, right, so this would be equals to, okay, let's compare coefficients. So this is going to be a plus bx squared, right? So let's do this comparison. So the constant term is equals to a, the x squared term over here, so this one over here is going to be equals to b. Okay, and this one is going to be equals to 0. So what does this mean? Means that this coefficient is going to be equals to 0. Okay, so over here we can actually take note by comparing terms, right? So over here we have negative n times 2 to the power of n minus 2 plus 2 power n minus 1 is equals to 0. Okay. Okay, because the x term is 0. Okay, so we can solve n plus 1 over here equals to n times n 2n minus 2. Okay, so let me consolidate this one over here. So I have a 2n plus 1 over 2n minus 2 is equals to n. Okay, so let me use the law of indices. So 2n plus 1 minus n minus minus 2, right? So over here, 2, I have 2 to the power of 3 is equals to n. So n is going to be equals to 8. Okay, can you see what's going on over here? If you want me to be a bit clearer, I can do this, right? So n minus n is 0, and then 1 minus minus 2 is going to be 3. Okay, so this is how I find the n equals to 8. Okay, so this is part 2. And using this, now I can find the value of a and b. So the value of a and b is just a simple comparison of this term and this term a, right? So a is going to be equals to 2 to the power of n. So this is going to be equals to 256. Okay, and last but not least, okay, this annoying thing is going to be equals to b, right? So and then this annoying thing would be n minus 1, 2 power n minus 5 plus n times 2 to the power n minus 1 is going to be equals to b. So now we know the value of n, right? So n is this, n minus 1 is 7, 2 to the power of 8 minus 5 is 2 cubed, plus 8 times 2 to the power of n minus 1, like this. Okay, I'm just going to use the calculator for this. So b is going to be equals to 8 times 7 times 8 plus 8 times 2 to the power of 7. So I will have a 1472. Okay, so like that. Okay, can so let me like recap on what's going on over here. So usually the first part they'll ask you to expand the unknown n, right? So I have a expansion. I will use the binomial theorem to expand for the first 3 terms. You just follow how many terms. So I have this over here, right? So and then for part 2, because we are expanding these 2 brackets, so means that I will need to replace this with my expansion just now, okay? And later I'm going to do this expand over here, and then this one expand over there, right? And I just observe the question. I just need to expand until and the x squared term. So means that I just need to expand the constant term, expand for the x term, and expand for the x squared term. This one I'm skipping because 2x times this will give me an x cubed term. Okay, it's going to give me an x cubed term. So I will not expand this term, and I can just stop there. And how do I do this? I will just need to compare coefficients. So this one, right, because this is technically equals to this, right? So I just compare this, I compare this, and I compare this. Alright, so and then I will get my n equals to 8. I get this, I get this. Okay, so I hope that now, so you will probably feel a bit overwhelmed now, okay, because there is a whole new world of expansion, and getting used to the, like, you are not sure on what's going on, alright? But my advice to you is get used to the notation, and I want you to see that the coefficients you can pull all to one side, all the x push to the other side. Okay, one more time, pull all the coefficients to one side, push the x to the other side, so that you can look at the terms clearer. Okay, you can look at the terms clearer when you do your expansion. Okay, so don't worry too much. We will do the exit pass. Okay, complete the exit pass, and I will be going through the exit pass in more detail when we come back. Okay, and the exit pass will cover some of these questions in detail. Okay, and it will feel a bit more like the exam style questions. Okay, so now this binomial theorem is a very powerful theorem where we can answer difficult questions like this. Okay, but I believe that once you do more and practice more, you'll be able to get the hang of it. Okay, so we are done with this chapter. So we are done with binomial theorem. So one more thing that I want to summarize for this chapter is, for the first part, okay, for the first part, what we have over here is the n factorial notation and the n choose r notation and the Pascal triangle thing. Okay, and in part 2 what we did was we expand this generically, like we did a simple expansion of this, right? We did a simple expansion of this, and we observe a pattern, and the pattern is actually the general formula for this, which can be in the form of n choose r, a to the power of n minus r, and b to the power of r. Okay, and at the same time we need to know some standard results for n choose r in case the n is an unknown. Okay, so n choose 2 would be like this. Okay, so it'll be good to memorize lah. Okay, and last but not least, we will apply this sum of n choose r, a power n minus r br. We'll apply this when we do the expansion. Okay, so for a, this would be descending powers, right? This one over here would be ascending powers. Okay, and one last thing is that n, because we have n, right, so there will be an n plus 1 terms. Okay, and the last skill that we need is to instead of expanding the whole thing fully, we have to locate a certain term, correct? So sometimes we need to look for T8, and then this one is r equals to 7. Sometimes we have to look for the term independent of x. So for this one, the power, once you gather all the power equals to 0. So for example, it may be a 2r minus 1 equals to 0, and then r equals to some number, that kind of thing. Okay, so make sure that the r must be, oh yeah, by the way, r will be 0, 1, 2, all the way to n, and r is a whole number. Okay, so the moment where you feel that the r is not a whole number, then something is wrong already, and then you need to double check. Okay, so I will leave this here like this. You try the exit pass questions. It's going to be a struggle, but I will discuss when we come back to school. Okay, alright, so all the best. You survived this 2 hour plus video, so I hope you learn a bit more of the power of binomial theorem, and then you can apply it when you answer your questions. Okay, that's all. Okay, bye bye.